Do you know what makes an LLM speak image? I'm going to spend the next 3 minutes trying to explain what makes an LLM a VLM. And I'm going to start from an example. An LLM, what it does is that it takes a sequence of words. You are a helpful assistant. Could you please describe to me what I can cook for dinner? Then what happens is that it breaks this sequence of words into tokens. You can think of it as individual words, and sometimes it's even smaller pieces of words. Then it does an encoding of the words, which means that it's going to take every word and compute a vector of numbers. I just wrote out the word here so you can see the correspondence, but it's really like just a long string of numbers. One string for every uh, word in the sequence, or every token in the sequence. Then what it really does is that it just, for this sequence, it has a text decoder which basically tries to predict the next word in the sequence. So what's the most likely word after all these words? Well, it's probably an answer, right? So in that string of answer words, the next thing would probably be you. So what it does is that it predicts you, and then it basically takes that you and puts into the end of the sequence. Now, then it's just gonna try again. So in this sequence that now ends on you, what is gonna be the most likely word? Well, it's probably could. So it would be sort of forming the sentence, you could cook X, Y, Z. Okay, so that's an LLM. It's just the next word predictor, basically. And you can think of it as having seen more or less the entire internet. And from that corpus of text and from some additional um, instruction tuning, it has learned how to predict the next words in a way that is useful to humans. I'm not going to go into the details. So the question is, how do you make this thing speak vision as well? So I'm gonna, in this video, tell you the high-level concept, and then I am gonna, in a follow-up video, try to explain in more details how you actually do it in practice. So before we had this sequence of words, we had a text encoder. Now, the natural thing to do is take an image and chop it into a sequence of smaller images. Maybe that's not natural to you, but that's at least that's how it works in practice these days. I just chopped it into 4 here, but it would typically be many more, so roughly 16 by 16 pixels, typically. Then you find another model that can do the same kind of trick. So take every one of these image patches, compute a vector embedding, so a string of numbers. And there's some magic sources I'm not going to mention here, but basically you can translate these numbers into a space where the text decoder can both sort of see words, but also see images through these patches. And then it just becomes a part of the input to the text decoder. And again, it's just going to predict the next word in the sequence. And now it's not only going to see the context of the words, but also the context of the images. These were the first sort of words I had on visual foundation models. I will follow up with more about how are you supposed to think about data when training these models, what can they actually do, what are some of the common models, both like closed source and open source, these kind of topics. But if there's anything specific that you would like me to cover, please let me know.